Да, 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 нормально, спасибо. Хоп.
Ladies and gentlemen, thank you very much for joining this session, which is a very important one in the context of modern times. I know you all have been here after a good lunch, and make sure that you're not asleep. And we've decided to keep the session very interactive with our participants in the panel, and we'll keep it lively as much as you may want to enjoy as much as being here. So the session today is chemistry and look into the future. And we all know how chemistry has contributed to development of mankind over the last centuries. But at the same time, today, the inventions of past have led to problems of present. When we talk about how the various inventions coming from fossil fuels, which has improved the mankind's lifestyle, at the same time has also had an impact on climate. So it's very important for us to really understand how chemistry should shape up and how it should contribute to the future of mankind. Today, to discuss with us, we have a very distinguished panelist. We have Mr. Haiyang Long, who is the chairman of board of China National Chemical Engineering Construction Corporation 7. Then we have Mr. Marcel Jürgen Krause, who is the technical director of GTL. To my left, I have Mr. Evgeny Korzykov, who is the chairman of Uzchemiosanat, which is the association of all the chemical industries in the country. And right in between Mr. Marcel and me, we have Mr. Filippo Di Pace, who is the CEO of the China National Chemical Engineering Construction Corporation. So let me start with Filippo. You know, Filippo, we talk about the innovations which chemistry has given us, and we have come across so much of products which chemistry has generated through various inventions and innovations. But at the same time, as I mentioned earlier, it has become a burden on the environmental impact it has created. So how do you think, what changes should the science of chemistry make in order to ensure that it becomes more recyclable?
Okay. First of all, let me thank you, Prakash, for this invitation in this panel. I'm very honored to participate. I'm very flattered to have the opportunity to address such a prestigious forum and distinguished
Filippo, you might have to be a bit closer to the mic. Because,
maybe I'll try to add this. So first of all, let me thank you, as I said. But back to your question, Prakash, I have to admit I'm not a scientist. I'm an engineer and a manager, and I believe science shall indicate the road, and we engineers should walk it. But when it comes to the chemical recycling, and specifically in this case to the plastic recycling, this is definitely an issue that chemical industry can address and must address. Just to give a dimension of the issue, in Europe, which is my territory, we collect roughly 30 million tons of plastic waste every year. Still, 85% of that is either incinerated or sent to landfill or exported. This is not only a sure source of CO2 emission, but also a waste for valuable resources. So the chemical industry is indeed determined to change this trend. How we want to do it? Well, chemical recycling is one of the most promising solutions that chemical industry can offer today. Substantially, this means recycling plastic into second-row feedstocks for the production of new chemicals. These processes may serve a double purpose. On one side, the reduction of the amount of the waste to be disposed, and simultaneously, they reduce the reduction on the dependence from the fossil feedstock in the chemical industry, somehow contributing to the implementation of the journey towards a fully circular economy scheme. Well, traditionally, the plastic recycling business has been limited to very selected material and mostly of mechanical type, see PET, for instance. Chemical recycling processes instead are available to supplement, to integrate these processes, especially when we talk about plastics made of different layers or heavily contaminated, or when the plastic streams from waste are not properly sorted. So the science has already developed some complementary solution that would just say reduce the impacts on landfill. Amongst the others, we can mention, of course, the full conversion, the depolymerization processes, and the dissolution processes, which a different level of, say, conversion and reduction provide secondary raw feedstock, which can be re-injected into the production of plastics at different stages during production. There are several major investments being announced on these technologies, and we are really looking forward to participate into this in this journey. These applications are gaining more and more momentum in different industries. We have seen the application in the automotive industry, in some of the white households, but still in a very dedicated sectors. But there is an increasing interest in participating in this one. So these processes are meant to bend the linear economy, produce, use, dispose, into a more circular type, from cradle to cradle. CC7 is particularly active in this field. In particular, CC7 Europe has one of the mission in its agenda. It's exactly to partner with worldwide technology providers and other industrial partners for the implementation of all these three routes, with an eye to combining them into a more integrated solution, more energy efficient, and basically more responding to the needs of a possible application on large scale. As a side note, we should also say that all of the applications which I meant are very largely depending on the continuous availability of recycled feedstocks. As a matter of fact, all the previous attempts to upscale these kind of technologies have found tremendous challenges in the availability of the recycled feedstock, because this turns to be a much larger issue, which involves collection and separation of the waste streams, and that require, of course, partnership with local, national organization, government. These are a vital part of this journey. For instance, the adaptation of the collection system and the segregation mode of certain streams require specific attention. Second, there's a regulatory framework, or we may say a deregulation in certain cases, for the applicability of these recycled polymers for their production and distribution. And finally, more importantly, I would say, there's the impact on the changing of habits of the consumers. This will, in my opinion, prove to be of the utmost importance. So in a nutshell, chemical industry can be a driving force for the reduction of its carbon impact, absolutely, but that's not a journey that a single industrial sector can take on its own. I believe that there should be a more holistic approach, including the regulatory framework, of course, the availability of capital and the willingness to invest in this technologies and projects, and large investment also in communication and in to win the buy-in of the people in a way to clearly support the change of their consuming and disposal habits.
Thank you, Filippo. I think you brought in a few good points, and particularly with your experience of what happens in Europe, and that brings a very interesting. Since Mr. Korzykov is with us, and I would want to understand. I mean, you being the head of the Chemical Industry Association, and there's a significant consumption of plastic, PET, and other products like that. So, is there a collection mechanism, a municipal collection mechanism, and how much is recycling happening in Uzbekistan? And how much of that recycling is mechanical or chemical, or what are the steps you as the chairman of Uzchemiosanat is wanting to take to ensure that the plastics that we consume in Uzbekistan does not get into the landfill but is recycled?
Спасибо за вопрос. Значит, по нашим планам.
So according to our plans for the chemical industry, we are focusing on the biodegradable plastics, that is, and based on the milk acid, lactic acid, and also recycling the secondary inputs materials or reuse of the used materials. So if you have large amount or large quantities, then we can actually also use the second use plastics.
You brought a very interesting subject of biodegradable plastics. Now the question is, and which again, Filippo, I'll take it to you, is biodegradable scalable? Because the fact is that today when we talk about biodegradable, we talk about the science of chemistry coming from the science of agriculture, because we say that some of these products could be derived from farming products. We talk about ethyl and methyl coming out of corn and maize and sugar and other things. But given that we have to create a balance between human consumption and between what is required for chemistry, and with the population growing so much more, is biodegradable scalable? That's for you, Filippo.
It's a very interesting question. Thank you very much for that. And it's indeed a very interesting challenging as well to address. Well, biodegradable plastics have the potential to be scalable. But there are some challenges that need to be addressed to ensure their effectiveness, their sustainability from all points of view, not only environmental, also financial, economical, as an investment. Some controversial points are surrounding the production on the environmental side, on the logistics side, on the marketing and the regulatory perspectives. Still, maybe it's worth mentioning that not all the biodegradable plastics are bio-based. There are biodegradable plastics which are indeed based on fossil rock, which could be compostable and not degradable, compostable both at home or on an industrial digester plant. Nonetheless, the biodegradable compostable plastics are, say, regarded as very much to a solution to the crisis, I would say, of the plastic waste. This is probably the biggest environmental challenge we have today as a mankind. On the other hand, the questions regarding the degradable plastics and their potential to be upscaled in large industrial production still need to be addressed. That's because some of these biodegradable plastics only degrade are designed to degrade under certain specific conditions, pressure, moisture content, or specific bacteria present, and would not degrade in a typical landfill or in a marine environment in real life as much as they are expected to do from lab. In effect, this may lead even to the accumulation of microplastics, which are considered even more dangerous than for the food chain and for the health of the people and of the environment, of course. The question is, can we really scale up the projects? Can we have a large enough production of biodegradable plastics to replace the traditional plastics? Well, the answer is not straightforward, and it's more complex than it seems to be. As you rightfully said, there are a number of factors influencing this one. One, now I'm talking as an engineer, as an entrepreneur, one of the main challenges of biodegradable plastics today is their cost. Still, biodegradable plastic today costs more than the traditional plastics. This is due to several factors: the cost of the raw materials, the cost of the energy to produce them, maybe also the lack of economy of scale in this field. But until the cost for the production of biodegradable plastics can be reduced, this would represent really a big challenge to scale up their production in a way to replace the traditional plastics. Logistics is also a big challenge around this biodegradable plastic, especially when they are bio-based. The logistics involves both the supply chain to produce them, but also what happens after their disposal. To make the fully circularity, let's say, of a biodegradable plastic, we should consider that we need to really rearrange the collection systems in a way that we can offer to each one of this polymer the right environment where to degrade, in a way to avoid its unwanted side effects. And another point I may want to take out is that consumers, users of these products may also not be fully aware of the proper disposal methods, or in certain locations, certain geography, in certain economies, they might not have access to composting facilities or recycling facilities that can handle this material. Now, if biodegradable plastics are not disposed properly and they end up in landfills or ocean, they would pollute just as much as the others. So this is something we need to be aware of. Some investments, maybe we should reinforce the concept of proper identification of the material and proper identification and communication about the handling of this material in our everyday life. Then again, marketing, regulatory environment need to be addressed. Today, just for the benefit of everyone, just let's be remembered that we don't have a standard definition of biodegradable plastic universally accepted. Of course, there's a number of law, a number of indication, European norm, and in my case, but all over the world, that define this one. But they slightly different or substantially different from one another. This creates some confusion, not only in the consumers, but also in the businesses. And furthermore, more general concern about the scalability of the biodegradable plastic, especially of the bio-based one, is that, okay, we may have unintended consequences, like deforestation, because we need more space to grow the crops that we use for for this material as feedstock. There's even the concern that indeed the production of the massive production of biodegradable plastics could even end up in increasing the greenhouse emission, especially when the energy used to produce them is not coming from bio-based, but coming from fossil fuels. Nonetheless, I think that biodegradable plastics also offer advantages that cannot be ignored. The challenges need to be embraced and resolved. These materials need to decompose in a controlled environment, as I said, so that they do not contribute to the accumulation of plastic waste. And the use of renewable materials to produce biodegradable plastics reduces dramatically the reliance on non-renewable sources. And this is a very positive step towards creating this, what we want in a more sustainable future. So, just a conclusion to your question, Prakash, no matter these controversial points need to be considered, also the advantages should not be ignored. We should, as CC7, we are trying to embrace this challenge. We are exploring how we can upscale the production of biodegradable plastic, even here in Uzbekistan itself. We're just completing extensive feasibility, technical and economical feasibility study for a large-scale PBAT plant, which is a compostable polymer made from fossil fuel. And hopefully, I hope I can come back to you with some positive news in the near future about this one. But all in all, the production of biodegradable plastics should just be regarded as a part of the solution of the problem of the plastic and the polymers industry, not the only way forward. But together with the other technologies and applications which are coming more and more available on the market and proven technologically, I really believe that an upscaling projects on biodegradable plastic may become a reality.
Thanks, Filippo. That's great insight. And you mentioned about composting, and I believe that there's a lot of technological innovations going on in development of enzymes, plastic-eating enzymes. And I think once that happens and once it becomes commercially viable, then we'll have one day where the enzymes will be inbuilt into the products. And the moment the products are disposed, the enzymes will eat it up. And it will automatically get composted. And probably one day that will resolve the issue of all the degradation and, and the lack of decomposition of plastics. So I'm hoping that. But, Mr. Long, taking you to the next question, of course, is the chemical industry is largely known to have a very heavy carbon footprints. And the world is trying to move towards net zero carbon. And the demand for chemical products is increasing as the population is increasing. So how do you think what the chemical industry should do to address this? And this is for you, Mr. Long. Yeah.
非常感谢主办方邀请我们来参加这个论坛，也非常高兴，也很荣幸参加这个论坛。CC7是一家中国公司，是一家集在化学工业领域及投资、建设、营运的一家国际公司。但我们在去年跟乌兹的能源部还有 UKS 也签了一系列的合作协议。那么这些项目就是集投资、建设、营运，可能在最近这些项目就会落地。我们作为一家化学工业的公司，那么怎么来减少碳排放？这个也是我们一直来在思考的问题。因为我们正处在这个行业当中，减少碳排放和实现零碳， 这个仍然是一个需要解决的一个复杂问题。目前，石油和天然气
As you noted, there are a number of questions which are not easy, which must be resolved.
这个占能源行业温室气体排放总量的15%。
Now, many of these issues are now being addressed partially, and possibly we don't yet have that 50% mark as regard the solution, but they have made significant progress.
还有使用的一些技术，还有投资的经济可持续性。
In order to implement the new technologies, we also need to think about the issues of investments, using which we can develop and we can actually bring in modern progressive technologies. Furthermore, we need to think about, indeed, the issues related to legislation, because legislation is not really on a quite acceptable level. So we need to actually increase the amount of recycled input materials for all kinds of industries. We need to promote investments because they'll be helping us to to conserve the climate, to safeguard the environment. In particular, we need to promote the development of solar energy. And to this end, a lot has been done already. China has set a goal for itself to reach the carbon neutrality by 2060, and we, CCA7, are focusing on zero carbon emissions and are actually implementing a number of strategies for assessment of investments, implementation of projects in some of the countries. So we are trying to join a chemical production plant in Uzbekistan with the big solar power plants with a capacity of hundreds of megawatts. These programs, these plans can enable not only enable the additional source of environmentally clean energy in the but also it will have positive impact on the overall financial capacity of the project thanks to the system of carbon credits. In some parts of Malaysia we are planning other projects and other solutions such as implementation of the systems such as CCS system, storage of carbon in order to link CO2 and transforming it into the other forms so that to reuse it.
that China has set a target of 2060. And there are a few things, of course, legislative framework becomes very important. Enhanced use of recycled material becomes equally important, and more application of renewable energy. I think these three would be a very, very important to really go towards that net zero target. Let me come to Mr. Krause. You know, GTL is involved in large chemical projects in the country, and you know, you are setting up a full value chain, including you know, how do you use various byproducts coming from GTL into more value-added chemical products. So, what do you think, in your opinion, and keeping in view various factors with respect to, you know, we're talking about sustainable products, we're talking about recyclable content, and we talked about biodegradables, and all that is good for the earth. So what, in view of all that, what do you think could be an optimal basket of petchem products for Uzbekistan? Of course, keeping in view the growth path that Uzbekistan needs to herald into. So what's your view on that?
Thanks for the opportunity to speak. I think the Uzbekistan GTL project is actually a real and vivid example of a new era and transformation currently underway in the petrochemical industry in Uzbekistan. We're constructed in the Kashkaria region in the south of Uzbekistan, and in terms of implementation, we're one of the biggest investment projects, not only in Uzbekistan, but in Central Asia. The main objective, and I think this speaks to your question, the main objective of our project is to increase the volume of deep conversion of natural gas and monetizing it, and to build energy independence in the Republic through the implementation of innovative technology. Today, we produce finished, value-added, and what's equally important, environmentally friendly products that meet the highest international quality standards. We do this from purified methane sourced from the Shirtan gas chemical complex located about 1 kilometer from our plant. The novel production of these products helps to build the beginning of a full supply chain. And one of the most interesting things about a GTL plant is that while today we produce products that are basically fungible with products that have been made for 100 years through crude oil refining. Today we do this by building molecules and getting really, really pure products that can actually now become the building blocks for further industry. The Uzbek GTL plant produces about 1.5 million tons of product a year. But what's worthy of note, and what's not really mentioned in our capacity, is that we produce almost 1 million tons of water. And in producing that water, we basically start to close the cycle and increase or decrease, I guess, the environmental impact of producing products that have traditionally been produced in a manner that's relatively heavy on the carbon footprint. For the economic input, the plant converts natural gas into finished products that are in high demand on the world market and which cost many times more than the cost of production and our raw feedstock. In particular, the kerosene that we produce for aviation fuel is much, much cleaner and of higher quality compared to kerosene derived from crude oil. Oops. Our diesel also meets the very highest quality standards of Euro 6 diesel. Actually, it's much better than Euro 6 diesel. So to speak to your question about what's the optimal basket of petroleum products, I think there's three things that answer that question. Certainly in Uzbekistan, we have a unique geographical position We're one of only two double landlocked countries in the world, and that represents a challenge for bringing things in and also for sending things out. So the first criteria, I think, is to think local, because the transportation is an issue. The second criteria is leveraging the existing infrastructure, and that's certainly how the Uzbekistan GTL project was formulated. We're leveraging an existing plant, Shirtan GCC, that's been there in more than 20 years, and now taking some of their leftover products and deep converting them into really high value products. And the last thing I would say is leveraging the chemistry to not add to environmental degradation, but actually to protect or preserve the environment. And here we definitely have quite a wonderful advantage in that we can produce water that we consume internally and that can also be consumed externally, and particularly in a country where water is in very short supply.
Thank you. Thank you. That was very good narrative on what you're doing at GTL and how you are broad-basing the product basket, keeping sustainability and circularity in mind. I would want to ask Filippo that Marcel mentioned about monetization of gas, and of course having fossil to be burnt as fuel is not the best way to use the fossils, and monetization is the best way, if you really ask. And given that Uzbekistan is moving towards more and more footprints on renewables, which means hopefully more and more fossil fuel will be available for monetization. And you are looking at very large projects which are gas-based in Uzbekistan, whether it's MTO, MTP, and various downstream products. How do you see an impact of fossil fuel being used for greater monetization activities, and how would that bring about a larger change in product availability in the country, and how would it benefit Uzbekistan?
As usual, you pick up the right points, Prakash. Indeed, CC7 is very much active in Uzbekistan in several projects which involve the conversion of gas into much more valuable products than fuel. But it's also worth mentioning that we're trying to connect this production with a certain environmental awareness somehow. This as an economical value, not only in the direct on the monetization of the gas that we do through the MTO, MTP plants that we want to produce, but also as a participation, let's say, to the journey towards a circular economy, which I think that Uzbekistan has fully embraced already. If you look around you, it's easy to understand how much chemical industry underpins every side of our life and our existence, and what could be the footprint in the change imposed by the chemical industry to our lives. For the clarity, chemical industry is responsible only for a marginal part of the greenhouse emission today. 4 to 4.5% of the overall worldwide emission, greenhouse gas emission, can be directly attributable to the chemical industry. When you compare it with transportation, with energy production, simply burning gas for energy, this makes a lot more of difference. On the other side, we want to meet and beat agreement made in Paris on emissions. We want to meet and beat certain industrial targets and still maintain profitability of our investment, still maintain a certain attractability of investors to cooperate in the realization of this type of initiatives. CC7 is very, very much active on this one. We are trying to associate to our plants carbon capture sequestration units, for instance, in the methanol unit, with the purpose to reintegrate this CO2 into the production of methanol. Of course, we are not alone again in this journey. We develop this with world-scale technologies providers who are embracing the challenge together with us. It's an enormous amount of activities that need to be done. We can look around it in several ways, but indeed, as you're right, there are much more and better ways to monetize, to extract value, even from fossil fuels, and mostly we can try to do it in an environmentally safe manner and still maintain a profitability and a high level of attraction towards these investments.
Thank you. You actually brought in a very good point here, saying that the real carbon footprint from chemical industry is actually insignificant when you compare to the carbon footprint from the transportation, for that matter. And that's the reason the more you move away from, move fossil fuels away from transportation, the more you reduce the carbon footprints. And I think Uzbekistan, with its objective of adding more and more renewables, is actually moving in that direction. And that's really, really very, very productive for Uzbekistan to move towards its goal of net zero in near future. And let me come back to Mr. Korzykov. In Uzbekistan today, you have 3 major ammonia producing facilities: Navoy, Chirchek, Fergana Azot. And all the 3 facilities have conventional ammonia. And there's so much of talk about the green ammonia, the blue ammonia, and the world is just trying to catch the race. That who is the first one to go to put in more and more of green ammonia and blue ammonia? Have you started thinking about it? And what in your opinion is going to work for Uzbekistan, the green ammonia or the blue ammonia? And do you have any time frame to have your first capacity of green or blue ammonia coming in the country?
Да, это очень интересно.
Yes, that's a very interesting question, because the journalists, well, the ammonia is produced from hydrogen, and the journalists have come up with different names for hydrogen, be it green, blue, gray. They have used a whole palette of colors. But let's just stop on blue and green ammonia. Yes, most of the companies today are producing nitrogen-containing fertilizers. They use for chemical reaction the natural gas, and the problem with this raw material, this input, is that the natural gas itself, certainly our resources, our reserves are being depleted, and based on the assessment of certain experts, it will be enough just for the next 50 to 70 years. And plus, on top of that, byproducts in production of the blue hydrogen is the CO2 emissions, so-called carbon footprint. Well, in the last 20 years, according to the data of the International Expert Group on Climate Change, which is acting under the UNFCCC, the average temperature on the planet should rise by 2.5 degrees, which, as they say, is impacted by the human activities. Considering this problem, not only chemical companies, but also representatives of the other industrial sectors are looking for new solutions to reduce the carbon footprint, and they are implementing these methods in their chains, in their production chain, to care for the future generations. One of the solutions is actually use of green hydrogen, synthesizing these substances. This technology is quite well known already for its electrolysis of water, and it's notable that emergence of the chemical industry in Uzbekistan actually has started with the green hydrogen in 1939 in Uzbekistan. Operation in Chirchik was launched, chemical fertilizer production. They used clean energy from the local hydropower plant and produced hydrogen using electrolysis of water. So the ammonia which was produced in Chirchik in 1939, it was exactly the green hydrogen. And hydrogen as a fuel, as regards its emissions, it's very good. But to generate hydrogen, I mean, for electrolysis of water, you need a large amount of electricity. Until recently, such a source of green energy was quite limited. Along with the development of the this industry, I mean, for photoelectric solar power plants, now the efficiency rate has gone up, and respectively, there is capacity to generate electricity with the cleaner methods without the carbon footprint. But so far, the technology for production of the green hydrogen and green ammonia out of it, from pure economic perspective, is loss-making. So green ammonium, so it's so far its price is higher by $150 to $200 than the one produced from natural gas, so-called blue ammonia. So that to produce all these issues, then we need to start producing it. Set an example, being the first, and well, not to convince, but actually to offer the consumers to choose for themselves what they prefer. So whether they support the further development of life on Earth, or they want to live and leave nothing to their successors, descendants. So what Aero Product and ACWA Power are offering, the project for building the green hydrogen facilities, and they are welcomed by our company. Those programs, which are designed globally for reduction of the carbon footprint and to reach zero carbon rate by 2050, we also will be making efforts to join this program, to develop produce hydrogen to replace chemical processes at least by 25%. Well, I think that we will join this initiative. And so today, Uskimia Sanoa, jointly with the ACWA Power, is actively working on designing the pilot's device in Uzbekistan to develop green hydrogen. So green hydrogen will be used in order to produce ammonia and the carbamide, the fertilizer. So far, this device will produce 3,000 tons of hydrogen per annum, and so we can actually produce 17,000 tons of green ammonia, respectively. So this green carbamide or urea, we'll start selling it, and we'll see. We'll see how our entrepreneurs, both domestically and in the domestic market or abroad, how will they perceive whether they will want to invest or invest their money into the development of green technologies. So subsequently, it's projected that with the positive results, which will be about creation of the large production capacity of the green ammonia, up to 500,000 and about 1 million tons of urea using green technologies. And here we will need to create the capacity on electricity about 2.2 gigawatts. That's quite a large capacity, and we can actually state with confidence that. So we'll try to be the pioneers in production of the green ammonium in Central Asia, and so in turn this will be an example for our good neighbors, and it will have positive impact on the environment. Спасибо.
You really brought a very interesting point that actually at Chirchik you are producing hydrogen by hydrolysis process much early before the world today is talking about it, and which means that you certainly have a pioneer position in terms of thinking ahead of times. And it's good to know that you're looking to take it forward, scale it up, and you're working on a project to produce green ammonia and carbamide with green ammonia, even though it's a small quantity. But do you think that the consumers are willing to pay a higher price, or will there be a price differential between a conventional carbamide or a green carbamide? Mr. Kozikov?
Значит,
So the chemical effect to the population, I can say that the population of the Earth is increasing. 81 million people, and in our country also there is a speed increasing of our population. And the food security and food security also depends on these chemical industries. So we have to use chemical industry to ensure food security. But chemical industry is giving us complex decisions on these high advanced technological decisions. And the GCM system is also working. It's reducing consumptions in agriculture. The company that are in our structure, we are working on development on the program that ensures the security, stability, and economic friendly system for every our organization. And the consumption is increasing each year by year, so we have to develop such kind of systems to reduce it, and the investment in this sphere is also very effective. We're making competition between the experts in the sphere to develop them for development this program. The footprint, footprint of chemical industry in agriculture the use of such kind of the fertilizers are in low the level, so many companies is implementing the inhibitors in their operational system because these inhibitors are effective in this, and the use and useful useful substances for plants will be higher. Yeah. And agricultural planting is increasing 20-30%. I'd like to add on a blue ammonium. Why it's called as a blue ammonia? There we can we have to. It's indeed it's a green ammonia, and we have one step to make our ammonia to make it a blue one. And we have to work on storage of this direction, and now in chemical industry of Uzbekistan is working and developing it.
That's a very nice insight on that. And I'm sure all our panelists, they brought in some very useful insights and very futuristic. When we discussed about how the chemistry can be more biodegradable, how we can have more recycling. We talked about the future of ammonia, both in forms of blue and green, and how we can bring more monetization of fossil fuels. Because these are certainly the future steps which the chemistry has to take. And we have to think today. If we don't think today, we don't make our products sustainable, and we don't do service to the next generation, because we are already having the impact of global warming, the climate changes are happening, the global temperatures are rising, the glaciers are melting, and we have to act today. And I believe the topic that we had today for this session was just apt for the current moments, current situations, and I thank my panelists for giving their valued contributions to the panel. And I hope the audience did benefit from it, and please join me in thanking all the panelists. So I think we are just on time, and we may not have much time for questions from the audience, but I'm sure the audience can reach out to the panelists if they have anything to ask in particular. So thank you again. Thank you very much.